consume a bag, which means 6 family consumes 1 bag. That will lead to another aspect of proportion. What you do here is if you cross multiply like they said here, you have 10 times x is equal to 8 times 5, and that will be 10x is equal to 40. If I divide both sides by 10, I'll have my x to be equal to 4. Well, that doesn't fit in here. It is not possible for you to have 5 men doing the job for 4 hours. So that is absolutely wrong. So what we are going to do is to find out where the problem is. Yes, the problem lies here in the solution, which means we are not supposed to cross multiply. Now let me try and explain it very clearly first. You see that as this men decrease, here it's 10 and it decreases to 5. Okay, there's a decrease from this point to this point. It didn't increase, and the number of hours supposedly increased from 8 to 16. What that means is that a decrease in the number of men leads to an increase in the number of hours, as against this other one that an increase here leads to an increase here. As we increase 6 to 12, the number of bags consumed increase also to 2. But in this very case, we decrease the number of men and eventually we increase the number of hours by common sense. And so this is showing us something very different. This is a very different case of proportion. It's not a direct proportion. It is called an inverse proportion. Why? Because you have an increase leading to a decrease. Okay, so what we do here in the case of inverse proportion is that we take the proportion row by row. Yeah, so this row will multiply themselves out this way and this row will multiply themselves out this way. So what we are going to have is 10 times 8 is equal to 5 times x. Remember the case of direct proportion and the case of inverse proportion. So you go, this will be 80 is equal to 5x. If I divide both sides by 5, I'll have 16 is equal to x, because this will cancel out this and this will cancel out this to get 16. So you have 16 is equal to x, which means x is equal to 16. So this is what you do in the case of inverse proportion. Now I'm going to look at this very well in mathematics by looking closely at direct variation. When we talk about direct variation, we're talking about a variation that increase as well as an increase in the constraint. Now look at what happens here. If we say x varies directly as y, this is what you do. The sign of variation is your alpha. Variation does not refer to equal to. When they say something varies, it is not equal. It just varies. Okay, at that point we're going to see that. So x varies as y is written as this. So you can say x varies directly as y, or you can say x varies as y. Most times you could call this x varies directly as y, or you say x varies as y. Either case, you're having this expression. So what we are saying is that x varies as y is not yet an equal sign. If I have to remove, because we cannot work with this in mathematics, mathematics doesn't understand what the sign variation is. It has to be an equal to for it to be able to solve questions. So we have to introduce an equal to and introduce a constant as well. So it becomes x is equal to, this is the constant I'm introducing from the variation, is equal to ky. Okay, now if I want to find the constant here, I may have to divide both sides by y so that this can cancel out, and I'll have x over y is equal to k. Now this is an equation that deals with constants. We'll just take this as equation 1. This is the equation that deals with constants. So when you are having x compared to a constant, you make use of this equation. Variation, like we said, means proportion. So if you are going to see it the way it is, it's actually a proportional value. It can be compared in 4 terms. So if I'm working with the other equation that does not have a constant, I may have to compare it this way: x1 over y1 is equal to x2 over y2. Now this is the other equation that I derived from removing a constant, because the constant is just to duplicate this very formula into a 4-term equation so that I can have it in the form of proportionality. Now this is my second formula that I will have to use anytime I am working without a constant. Now let us go over and see some examples here. It says if y varies directly as x, if y varies directly as x, this word directly has helped us to define the kind of variation we are talking about. If y varies directly as x and y is equal to 20 when x is equal to 15, find the constant proportionality. Now the first question here says find the constant proportionality, so which means we are using the equation that deals with the constants, and it goes x, let's begin, varies directly as y. This is the formula for direct variation because it goes in a linear form. Then x is equal to ky, then x over y is equal to k. That is what we are having from our formula, and we can get solution 1 using this formula, and it says find the constant proportional when y is 20 and x is 15. So I have 15 over 20 is equal to k. That is the constant proportionality. There I can solve further to get 3 over 4 is equal to k. That if I divide both sides by 5, okay, 5 can go into both of the terms in the numerator and the denominator. So I'll have 3 over 4 is equal to k, and that's the least fraction I can get. I cannot break it further, so I leave my answer that way. I can say here that k is equal to 3 over 4. Now what if I'm going to solve for, is a find the value of y when x is 24. Now there's another comparison here again. The first one is that we have y as 20 and you're looking for y again when x is 15 and you're looking at x 24. So you are setting two values. For the second one here, you have the first x to be equal to 15. You have the first y. At that point, what is the y that was set against this x? You have 20. Then the second y is what we are looking for, y2. We don't know. Our x2 is what is given here as 24. So if I decide to use this other formula, let's see, I could just take one of these off. If I decide to use this formula that says x1 over y1 is equal to x2 over y2, that will be set as 15 over 20 is equal to x2, which is 24 over y2. I'm looking for y2. Now you have a fraction and an equal to in between. You can cross multiply very easily, and here you have 15 y2 is equal to 20 times 24. Now if I divide both sides by 15 so that this will leave, I'll have my y2 is equal to, this cancel out this, y2 is equal to, let me remove this, it's actually distracting me, it's taking my space. Here becomes 20 times 24 over 15, and what that will give you is 5 here is 3, 5 here is 4, 3 here 1, 3 here 8. So you have 4 times 8, which is equal to 32. So you have y2 is equal to 32, which is your final answer. That's just how you get your y2. The inverse variation is what we're looking at here, and it's very different from the direct variation in the sense that whenever a value varies inversely, the symbolic representation is 1 over. So here you have x varies inversely as y. So symbolically you're going to represent this as x alpha 1 over y. And we may want to find the constant here. Is the same process. If we say x varies as 1 over y, which is the inverse variation, and then we introduce a constant, so x will be equal to k 1 over y. What that simply means is x is equal to k over y, because k will multiply 1 here and you get k over y. Now if I'm going to find the value of k, that means I have to multiply both sides by y just to eliminate this y here, and I have x y is equal to k. So xy is equal to k is a formula, and this is the first formula that is taken to the constants. And if we have to eradicate the constant, what I mean is if we have to duplicate the formula by removing the constant, we are going to have this equation here as x1 y1 is equal to x2 y2. So this is the second formula. This one has to do with the duplicates and does not make use of the constants, while this other one makes use of the constant. So we're going to look at an example here. The first example we're picking is saying if y varies inversely as x, the underlying factor here is that y varies inversely. So you have varies inversely as x, and y is 12 when x is 15. Find the value of x when y is 20. Now you are given two values. The first one is that you are given the value of y1 as 12. You are given the value of x1 as 15, because the x1 is the value of x when y is y1. So we have the second value is find the value of x. X2 is what they say you should find when y2 is equal to 20. Alright, let's see what we'll do here. We're going to pick up this formula that duplicates, because here you don't make use of the constant. You have x1 y1 is equal to x2 y2, and that will give us, by substituting these values into it, you have 15 times y1 is 12 is equal to x2 is what we're looking for, x2 times y2, which is 20. Now I want to find x2. That means I'll divide both sides by 20 so that this can cancel out. So I have 20 goes into 20 here. My x2 remains here, which will be equal to let's see what can go here. 5 here, 4, 5 here, 3, 4 here, 1, 4 here, 3, which is 9. 3 times 3 is 9. So we have x2 to be equal to 9 as our final answer. Let's look at joint variation in this case, and we may look at what is stated here. It says sometimes a quantity z may vary directly or inversely as the products or quotients of two other quantities x and y. The quantities are said to vary jointly and there is a single constant proportionality. Now what this simply mean here is we have to take the underlining words. There is a single constant proportionality. Take note of this. Says to vary jointly. We'll take note of this. So it is the combination of two or more quantities. So let's take note of a very important concept here. We may be given that z varies as the product of two quantities. Let's say it varies as a product of x and y. So it's going to be x times y. Now this is where z varies as a product of x and y, and this is where z varies inversely. Anything inverse is 1 over. Z varies inversely as the product of x and y. You can take another example that says z varies as x and y, or you can say z varies as x and inversely as y. So whichever way you go, you are having a joint variation in the sense that it's combining two quantities. Now and in variation actually refers to multiplication. So when they combine two quantities together, they are referring to multiplying them together. Usually in joint variation you always multiply two quantities, two different quantities together, but they seem to have the same constants. Why? Because if we decide to remove this and make it an equal to, it becomes z is equal to k x y. That is the product of that, and this will become, for this case you have z is equal to k1 over x y. This is where you have z varies as the inverse 1 over the product of x and y, and here we say z varies as x and y. Now and there refers to time, so we have this to be in this format: z is equal to k x y. For this one you have z varies as x and the inverse of y, so we could represent it as z equal to k x and the product of y, 1 over y, which is this is 1. So whichever way, you know what to do in your joint variation. It's always combining quantity, and whenever it does, they are said to be in joint variation. We'll look at an example here. I could just take this off quickly. This question says, given that z varies directly as x and inversely as y. Oh, that's a lovely one. And that z is equal to 18 when x is equal to 45 and y is equal to 25. What is the relationship connecting z, x and y? Now that's the first question here. We may want to look at this solution, and it says what's the relationship connecting z, x and y? According to our question, it says z varies directly as x, so for direct variation is always linear, and inversely as y. For inverse variation it is a reciprocal, 1 over. So you see that these two things are combined together. It is not just one, it varies as x, directly as x, and inversely. So and refers to times, that is this dot I just put here, which help combine them. Remember we said joint variation makes use of multiplication to bind two different variables together. So we are going to represent this, and we said also that joint variation have the same constant. So this would become z is equal to k, just one single constant, of x dot 1 over y, which will be written further as z is equal to kx over y. So this is the equation for the joint variation. Now we go to the next question. It says also find z when x is 12 and y is 20. Now we're given initial value. They said z is 18, x is 45, y is 25, and another set of value z here we're not given, so this becomes z1 and this z2. For this other one, x2 and x1, I will take y1 and y2 for the other case. So x2 here becomes 12 according to what is given there. That's the second phase of the question. And y2 is 20. Now you see that there is already a duplicated formula here, so which means we have to duplicate this formula. And when we are doing that, all you need to do is just to make your constant the surface of the formula, then you duplicate. That's what we do whenever we're duplicating, and this becomes z y over x is equal to k. You can check it out, and when you duplicate, you have z y over x is equal to this for z1 y1 x1 is equal to z2 over y2 over x2. This becomes the second formula that we'll need. And I could just take a stroke here. I could take all this off. So I have my space. So what are we referring to? We are using this formula now over here, and it comes here and says z1 y1 over x1 is equal to z2 y2 over x2. And when we begin to substitute our value, we'll have it as 18 times y1, which is 25, over x1, which is 45, is equal to z2, which is what we're looking for, z2 times y2, which is 20, over x2, which is 12. So this will give me this value. I can cross multiply. Remember, anytime you have a fraction and an equal to in between, you always cross multiply. So this can go out this way, and I have 18 times 25 times 12 is equal to z2 times 20 times 45. Well, if I decide to divide both sides by 20 times 45, so that I'll have my z2 on its own, 20 times 45, this will cancel out this, this will cancel out this. So here I'm going to have z2 is equal to 18 times 25 times 12, all divide 20 times 45. Now when we decide to cancel out, 5 here it's 5, and 5 here it's 9, 2 here 10, 2 here 6, okay, 9 here 1, 9 here 2, 5 here 1, 5 here 2, 2 here 1, 2 here 1. So I'm having just 6 over 1. I can now say that my z2 is equal to 6. So this can be written here very well. z2 is equal to 6. That's exactly what we got. So you can check that out using your own method in your notebook while you look at how we solve it. Because of space, we are always going to have all these things jammed together, so we're sorry for that, and that's the way it works here. We may want to take another example. And this time around, the question says, given that W varies inversely as the product of U and V. So we say that W varies inversely as the product of U and V. Here we have W is equal to K 1 over UV. Because when you introduce your constant, you take away your proportionality sign, and you have W times UV is equal to K. So this is the first phase of the formula with the constants. And the second phase is when you have to duplicate. But let's see if we are duplicating here. They said, and that U is equal to 5. Sorry, U is equal to 25, while V is equal to 50. Find W when U is equal to 5. Oh no, that's not the correct question. There's a problem wrong with this question in the sense that we're not giving W. First stage of the W was not given, and U is equal to U2. This is the U1 and this is the V1, and the U2 is given also as 5 and V2 is given as 10. And you're asked to find W2. You cannot be having two unknown in a single expression, so it is going to be a wrong question. So we'll term it a wrong question. Because you cannot actually look for two things all in one. Except you are told that W1 is equal to W2, but that's not the case here. None of the parts in the question stated that. Alright, so this is a wrong question. We'll pick some other question.
This one is for world peace. Let's live together. When two become as one, the bond is there to stay. Then think of when that bond joins more